Hello everyone, my name is Akshay and today I'm sharing my presentation about day 14th challenge from IDC, and the topic is about recursive functions and base cases, and the challenge is to calculate factorial recursively. Okay, so you can look at this picture which has multiple boxes in it. So here if you look at the smaller box, here n is equal to 1 factorial of n minus 1. If n double equals 1, return 1. Okay, in the second box it's gonna be n is equal to 2 factorial of n minus 1. In the third box is equal to n equal to 3 factorial of n minus 1, and here at the end n equal to 3 factorial of n. So here what we are performing is, if we want to calculate the factorial of any value, then we will be starting from 1 and we will reach till the end, the nth number of the given number. Okay, but we repeatedly repeat the same process in multiplying one number with the adjacent number, that we continue till we reach the final number, right? So this process is called recursion. Okay, so let's look at the theory part of it. So what is a recursive function? A recursive function is a function that calls itself to solve smaller parts of the problem. Okay, the key idea is to divide the problem into smaller sub problems until you reach a base case. Okay, so what is a base case? A base case is a condition that stops the recursion. Okay, without a base case, the recursion goes on forever and causes a stack overflow error. Okay, so the smallest part of that function means the base case is the last operation that happens. I mean, that is the last condition for which the recursion operations will check, and if the condition is true, then the operation will stop. Okay, that's how it works. So let's look at some example. So here we take the example of sum of 1 to n numbers. Okay, so if my number n is 3, then I'll be summing up 1 with 2, and then then I will be adding with 3. Okay, so here I have my find sum of n. If n is equal to 1, return 1. Okay, until then return n plus find sum n minus 1. Okay, so this is my function. I'll run it, and here my number is 5. I want to calculate the sum of the numbers from 1 to 5. Okay, so the the elements will be 1, 2, 3, 4 and then 5. If I do that, my output will be 15. So I am doing the repeated operation multiple times till I reach 5. Okay, so now let's look at Fibonacci number. So I'll explain what is Fibonacci number. So it is you can take the series as 0 and then I'll be adding 1 to it. Okay, 0 plus 1. So now I'll add 0 and 1, that will be 1. Now then I will add 1 and then 1, that will be 2. And then if I want to get the next number, what I will do is I'll add 2 to the previous number, then the next number will be 3, and then I'll be adding 3 with the previous number, that is 2, then the answer will be 5. And then I will be adding 5 with the previous number 3, the next number will be 8. So this is how that is called my Fibonacci series. Okay, but my indexes will be as usual 0, 1, 2, 3, 4, 5, 6. Okay, So here I have my function fib. Okay, if n is equal to 0 or n is equal to 1, return n. Okay, till then fib of n minus 1 plus fib of n minus 2. If I run this, and if I want to calculate the Fibonacci of number 2, then the answer will be 1. But if I do it for 3, it will be 2. If I do it for 4, see the answer will be 3. So this is my index. Okay, if I do it for 5, eight, 34. Okay, so if you look at some of the recursive function in our day-to-day life, you can see that in math we use it for factorial, Fibonacci and GCD calculation, and here in string and numbers we use it for reversal of the string, palindrome, and sum of the digits, like this. So we have multiple use case in our day-to-day life of the topic recursive functions. Okay, so if I want to look at the challenge is to calculate the factorial recursively. Okay, so this is my function factorial. If n is equal to 0, if n is equal to 1, this is the base case. Okay, this is the last case at which the recursive function should stop its recursive process. If this is the case, then return 1, else return n into factorial of n minus 1. Here if I take the number 5 and print factorial of number and then the value. If I do this, so factorial of 5 is 120. Let's look at another number. Let's say 4. Okay, I'm so sorry. Yeah, so the factorial of 4 is 24. So this is my presentation about recursive function today, and if you really like my presentation, so share your valuable feedback and do comments. If you have any doubts, you can ask me at any time. And yeah, thank you so much for your time and have a good day ahead.